Now let us understand the math part behind the scenes. Now here Xij, what is this? I'll explain this using this diet program here. So there are 3 diet programs. I would say Atkins diet program is your X1, GM diet program is X2, and South Beach diet program is X3. And you have 12 entries here, right? So if I were to refer to the weight loss of the first person, I would say it is X11. Weight loss of the first person assigned to Atkins diet program. If I were to refer to the second person, I would say X12. Weight loss of second person assigned to Atkins diet program, so on and so forth. Alright, so I can represent this in this way. Xij, wherein I is equal to the group and j is equal to the person. So Xij here refers to the weight loss of a person who is assigned to a specific diet program and the specific entry. I is equal to one of the 3 programs. One of 3 programs. And j is equal to one of 12 participants. So Xij is a weight loss of 1% represented using a small rectangle here. The weight loss of each person would not be exactly same as the average weight loss of that group. What do you mean by that? The average weight loss here is 4.5 kgs. Weight loss of any of these people is not exactly equal to the average. Most often than not, it won't be. So the average weight loss of one individual is 6. It is not equal to 4.5. Average weight loss of the second person is 2. It is not equal to 4.5. In that way, average weight loss of each individual, this is, sorry, not average weight loss of each individual, it's weight loss of individual would not be exactly equal to the average weight loss of that group. All right. And the difference between the weight loss of each individual to the average weight loss is given using EIJ, error. That is how it is termed, error. And the average weight loss of each group would not be exactly the same as the grand average. So if you look at this, the average weight loss of Atkins diet program is 4.5, average weight loss of GM is 5.3, and the average weight loss of South Beach is 7 kgs respectively, right? But the grand average is 5.6, and none of these values are equal to the grand average. And that is exactly what it means, right? And the difference between the weight loss, average weight loss of one group versus the grand average is given using a term called TI, which is treatment. If you don't like TI, give some other notation. That's absolutely fine. And the total IJ is given using EIJ plus TI, the total distance. That is the distance between each individual weight loss to the grand average weight loss is given using EIJ plus TI. That is what is written here. And I'm assuming that you guys know A plus B whole square formula. This is equal to A square plus B square plus 2AB. Why do we need to square it on both sides? Because remember the variance formula? Summation of y equal to 1 until n, xi minus mu whole square divided by n. If you do not take a whole square here, xi minus mu, this xi minus mu summation would always turn out to be 0, right? To ensure that the values do not get cancelled out, we were taking a square. On similar lines, we are taking a square here because this Eij can also be on the other side. Just to ensure that the values do not get cancelled out, we are squaring that on both sides. And when you expand it and try, when you find free time, you get to see that when you square it, 2ab gets cancelled out. And you'll be left with only ti square plus eij square. You can try it out when you find free time. And this is what you get. When you square this on both sides, this is what you would be left with. This term is called as sum of squares error. This term is called as sum of squares treatment. In the summation of those two is called as sum of squares total. Now, we were discussing about 36 participants being assigned to Atkins Diet Program, South Beach and GM Diet Program. And for each of these individuals, you have an EIJ term for each individual. So you'll have 36 EIJ values. And if I increase the number of participants to 60, the number of EI values also will increase because each individual will have one EIJ. And when you square it, obviously, this value is going to increase. So this value is going to be influenced by number of or by sample size, which is wrong. Your formula should not be influenced by your sample size. And if you look at this, it has n into ti. N is your sample size. If I increase n from 36 to 60, this value also would get increased. So this is also getting influenced by the sample size, which is also wrong once again. And if these two values increase, this value would increase. So these values get fluctuated, changed based on your sample size, which is wrong. It should not happen in that way. Hence, we try to normalize the effect. We try to ensure that these values do not get influenced by the sample size. Hence, what do? We tweak the formula a little. Look at this. So sum of square treatment divided by r minus 1 would give you mean square treatment. This will not get influenced by the number of samples that you have. And r is number of groups. In our weight loss program, we have 3 groups: Atkins Diet Program, South Beach and GM Diet Program. And we had 36 people. All right. And if you want to normalize sum of square error, and if you do not want this to be influenced by the sample size, you need to divide it by n minus r, where n is subjects and r is the groups. And this will ensure that the mean square error is obtained, which is not influenced by your sample. And if you take a square, ratio of this, you would get a value called F distribution. We will discuss about this when we discuss about linear regression. These values will come up. And from this F value, we have already done this. We looked at the Z table to calculate the p-value. We have also looked at the T table to calculate the p-value. And here we will be looking at the F table to calculate the p-value. And thereby you get a p-value, right? That is how you get the p-value for F distribution. And hypothesis we have already discussed, so we need not discuss once again on that front.